Good day, students. Welcome to part 4 of the New York High School Regents exam for integrated algebra. We're going to be going over questions 21 to 25 in this series. Remember, this document can be found on the New York State um, Education Regents website. And this is the August 2012 version. All right, let's go ahead and take a look at question number 21. It says, given that set A is 13579, set B is 246,810, set C is 2357, and set D is 12345678910, which of the following statements is false? So this is basically assessing our understanding of the intersection and union of elements of a set, okay? So to help us organize these elements and make it easy for us to see where they intersect or how they can unite, I'm going to make myself a matrix, and I'm going to create a row for each of my sets, and then I'm going to fill it in with their elements. All right. So let's see how many columns I'm going to create. The biggest set has 10 elements in it, so I'm going to create a 10 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay. All right. So first set is set A. So let's put that in the first row. So for set A, we have so let's say what this is column 1, column 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's fill in the elements for set A. Set A is 1, 3, 5, 7, 9. If you study these elements for a minute, you notice that they are a specific set of numbers. These are the collection of the odd numbers from 1 to 10. Okay? All right, let's make a row for set B and fill it in with its elements. Let's try a different color for this. All right, for set B, we have 2, 4, 6, 8, 10. All right, if you examine these numbers basically represent the even numbers from 1 to 10. All right, and then we have set C. Let's put that in the third row. Set C is given by 2, 3, wrong column. Remember, the columns have to match up. So 2, 3, 5, 7. All right? And if you look at this set of numbers, what do they represent? These are the prime numbers from 2 to 10, between 1 and 10. 2, 3, 5, 7 are prime numbers. All right, and then the last set of numbers, the last set is D, and the elements is just everything from 1 to 10. So let's fill it in. 1, 2, this is a different color. So for set D, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now it says which of the statements is false. Let's take a look at option 1. We have A union B union C equals D. So is this statement true or false? If it's true, then we'll move on to the next one, okay? When you're uniting elements of a set, you're looking for elements that's present in one or more of the elements of the sets, okay? So if an element is present in at least one, then it's automatically in the union, okay? If it's in more than one, that's fine, but at least one, it has to be in at least one to be in the union, all right? So let's unite A union B union C. We're going to just be considering any element that's present in any of these three that will be included in the union of the three sets, okay? So 1 is present in A, so that's included. 2 is present in B and C, perfect. 3 is present in A and C, included. 4 is present in B, it's good. 5 is present in A and C, included. 6 is present in B. 7 is present in A and C, included. 8 is present in B. 9 is present in just A, which is sufficient, so include 9. 10 is present in B. then you have the union of all three. Okay, all these elements are present in one or more of these sets. All right, so what is set D? Set D is everything from 1 to 10 as indicated here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are these two sets the same? They're the same. So guess what? Statement number 1 is true. All right? Okay, let's move on to statement 2 and see if it's true or false. Statement 2 says A intersect B intersect C equals to the empty set or the null set. Is that true? Where intersection basically means that an element must be in all three of the sets in order for it to be included in intersection, okay? So let's see if any element from 1 to 10 satisfies the intersection or the statement I just made. 1 is not present in all three, so it's not included. 2 isn't present in all three, is not included. 3 isn't present, is missing in B. 4 is missing in A and C. 5 is missing in B. 6 is missing in A and C. 7 is missing in B. 8 is missing in A and C. 9 is missing in B and C. And 10 is missing in A and C. So there isn't any one element that's present in all three. Hence, the intersection of the three sets is the empty set or the null set. Okay? So let's just take a look at this statement. What does this actually mean? It means that is there any number from 1 to 10 that is odd, even, and prime? Is there any number that satisfies that? Absolutely not. So that's why we have the empty set. Okay, this can also be called a null set. Null set or empty set. Okay? All right, so this statement is true. So statement 2 is true. So we have to move on to statement 3. Remember, we're looking for the statement that is false. All right? So statement 3 says that A union C is equal to 1, 2, 3, 5, 7. Is that true or false? So A union C, is it equal to 1, 2, 3, 5, 7? All right, so A union C is just any element that is present in at least one or more of these two sets, okay? So let's look at A union C. Element 1 is an A. That's good, so put that down. Remember, we're just focusing our attention on sets A and C. Anything that's present in one or more of these two sets will be included in the union, okay? So 1 is present in one of them, A, included. 2 is present in C, included. 3 is present in A and C, perfect. 4 isn't present in A or C, so it's not included in the union. 5 is present in A and C, is included. 6 isn't present in any of these, in A or C, so it's not. 7 is present in A and C, included. 8 isn't present in any. 9 is present in A, we included. 10 isn't present in any, so this is A union C. Is it equal to 1, 2, 3, 5, 7? Are these two sets the same? Absolutely not. This is missing. This has a 9, this doesn't have a 9, so this statement is false. So that means your answer is option 3. All right? Okay. So let's move on to the next question. Question 22 says, which expression is equivalent to 2x to the 6th minus 18x to the 4 plus 2x squared over 2x squared? Okay. So for this, I will show you two methods of doing this, okay? So method 1. Method 1 is elementary, doesn't require knowledge of the rules of exponents or the laws of exponents, but you just need to know how to decompose, okay? So I'm going to decompose every single term. 2x to the 6 is 2 times 6, x times itself 6 times, 1, 2, 3, 4, 5, 6, minus, if you break down 18, take out 2, 9, 3, 3. So it's basically 2 times 3 times 3. X to the 4 is 4, x is 1, 2, 3, 4. Plus 2x squared is 2 times x. And we're going to divide it by 2x squared. Okay, divide the whole thing by 2x squared. So I'm going to break down 2x squared into 2 times x times x. Now when you're reducing, if you want to reduce any term from the denominator, you have to reduce it from every term in the numerator. It's either all or nothing, okay? So keep that in mind. Now you notice 2 is common in the denominator. So I want to cancel out 2, so I must cancel out the 2 on every term in the numerator. 1, 2, 3. All those 2's have to be divided, okay? So when I divide the denominator by 2, I get 1. I must divide every term in the numerator by 2. So 1, 1, 1. And then next, the x's, the two x's in the denominator, so I need to cancel out two x's in the numerator, 2, 1, 2, 1, 2, and then 1, 2. Okay, so I'm going to divide by two x's. These two divide out. These two divide out. These two divide out. I put 1, and these two divide out. So I just divided the numerator and the denominator by 2x squared. All right, so my final answer is going to be x times x times x times x to the fourth minus 3 times 3, 9x squared plus 1 times 1 times 1 is 1. So the denominator is divided out completely, so we don't have anything in the denominator. So there goes your final answer. Okay, so your answer is option number 4. Okay. All right, let me show you another method of doing this, method 2. This one's a little bit more advanced. What I'm going to do first is I'm going to break this fraction down. Okay, since this is a common denominator, I can write this rational expression as 2x to the 6th over 2x squared minus minus 18x to the 4th over 2x squared plus 2x squared over 2x squared. All right. Now, I can divide this by 2. 2 goes here 1, 2 goes here 1. And then when you have x to the 6 divided by x squared, you're going to subtract these powers. The smaller from the bigger, wherever the bigger is. The bigger is upstairs, so 2 minus 6 upstairs. And then minus 2 goes into 18. 9 times, so 2 goes here 1, 2 goes here 9. And then you bring it down, you're going to have, let me write that again. You're going to have 9x to the 4 minus 2. Okay? So 9x to the 4 minus 2. Plus, and then these two are identical, so if you divide them out, you just end up with 1. Okay? Plus 1. So the final answer is going to be x to the 6 minus 2 is 4 minus 9x squared plus 1. All right? So you can clearly see that your answer is option number 4. All right, let's move right along. Question 23, it says in a given linear equation, the value of the independent variable decreases at a constant rate, while the value of the dependent variable increases at a constant rate. The slope of this line is the positive, negative, 0 are undefined. So let's make a real quick sketch of our coordinate system. This is known as your x-axis. And don't forget, your x-axis is your independent variable. Okay? And this is your y-axis. Your y-axis is your dependent variable. It's dependent on your x. Okay? So slope, if you look at your reference sheet, we know that slope is rise along the y over run, which is also written as y2 minus y1 over x2 minus x1. This is the formula on the formula sheet, on your reference sheet. And this can be written as the change, since y is your dependent, it's going to be the change of the dependent over the change in your independent. Okay? So all we care about is the signs here. We're told that as the independent decreases, decrement is negative. The value of the dependent increases. So if we want to calculate the slope of this scenario, we're going to have a positive change in your dependent over a negative change in your independent. So what is positive over negative? If the signs are different and you divide, you have a negative. Okay? So the answer is going to be option 2. So to illustrate this for you, let's draw a line. So we have a line like this with a negative slope. And if I pick 2 points on the line, a point here and a point here, when the independent is decreasing, what direction is that? A decrement in your independent means you're going backwards because x gets bigger as you go to the right. So this is decreasing in your dependent, and notice what happened when if you decrease in your independent, notice what happened in your dependent. It increased. Okay? So you have a negative change in your x or dependent resulting in a positive change in your dependent. And that's what's been spoken about here. All right? So if the signs are the same, it's going to be positive. Okay? If the signs are different, then you have a situation where it's negative. but you have a zero slope when there's no change in the dependent, when you have a change in the independent. I have undefined if there's no change in the dependent. If there's no change in the independent when you have change in the dependent. Okay, so this one is this one how this one the numerator delta y is 0, and then this one delta x is 0. All right, so that's what we have undefined. Undefined is up, down, and this one 0 slope is side to side. All right, so the answer here is option 2. Moving right along, question 24 says the volume of a cylindrical can is 32 pi cubic inches. If the height of the can is 2 inches, what is the radius in inches? So if you look at your reference sheet, you have the formula for uh, the volume of a cylinder. Let me just make a sketch. So let's say we have a cylinder like this. Pardon my sketch, it's terrible right now. So you have a cylinder like this. So the formula tells you that all you need is the area of the base, which is a circle, pi r squared, times the perpendicular height, which is h, right? So the volume is basically pi r squared times h, okay? All right, so let's write down the formula of v is equal to pi r squared, h. Let's list all the variables we need and the one we know, and then we're going to solve an equation, okay? So v, the volume, is 32 pi. R, the radius, we do not know what it is. That's what we're looking for because it said what is the radius. The height h of the cylindrical can is 2 inches. And what is pi? Some people think this is a variable, although there's an alphabet, there's a Greek alphabet that represents a number. So pi is a constant. It doesn't change. You leave pi alone. Okay? So you just leave pi as pi. So we're going to plug these values into our equation. R will remain R because it's unknown. So we're going to have 32 pi equals pi times r squared, and the height is 2. Okay? Let's rewrite this in standard form. We're going to have 32 pi equals 2 pi r squared. The constants come before the variable. All right, to get r by itself is a two-step procedure. We'll divide by 2 pi to get rid of this constant, and we root it to get rid of this square, okay? So let's divide by 2 pi, both sides. On the left, 32 pi divided by 2 pi is 16. And on the right, these 2 pi's divide out to r squared, okay? To get rid of this square, we'll do the opposite of square, which is root. So we root the left and root the right. And we're going to have r. Anytime you take the square root of a square, you have plus or minus. So r equals plus or minus 4. Okay? But since radius is a length, it's always positive. A length cannot be negative. So r is equal to positive 4 inches. So that is the radius of the cylindrical can with a volume of 32 pi and a height of 2 inches. Okay? So the answer is option number 4. All right, moving along to the last one. It says the expression 14 plus x over x squared minus 4 is undefined when x is. Well, if you try this out with your calculator, what makes a number undefined? If you test this with your calculator, is it when the denominator or the numerator is 0? Well, you can test it out. What is 0 divided by 1? It's just 0, right? Let me change the mode of my calculator. I can't put in scientific. All right, let's use normal. 0 divided by 1 is 0. And how about 1 divided by 0? 1 divided by 0 is error. Okay, so you have issues with dividing by 0. So you have undefined anytime the denominator is 0. Okay, so undefined happens when you divide by 0, because you can't divide by 0, it doesn't make sense. So to find when this is undefined, we set the denominator to 0 and we solve. Okay, I'm going to show you 2 ways of doing this, and you can pick whichever method you like the best. Okay, so method 1 involves factoring. You have to remember that this is a difference of squares, so we're going to use the difference of squares formula, which is a squared minus b squared equals a plus b times a minus b. Okay, so to do that here, I'm just going to root the first and the last, and then I'll add and subtract the square roots, okay? So I'm going to have x minus 2 times x plus 2 equals 0. To finish this up, I'll set both factors to 0. This is called the zero product property. And I'm going to solve for x, okay? On the left, I'll add 2 to both sides. That gives me x equals 2. And on the right, I will subtract 2 from both sides. That gives me x equals negative 2. So the two values that result in a 0 in the denominator and consequently an undefined rational expression is when x equals negative 2 or 2. All right? So your answer is option number 3. Okay, so let me show you another way of doing this. Method 2. This doesn't involve the use of factoring, okay? So for method 2, I'm going to solve it like an algebraic equation, a quadratic equation. So I'm going to try and isolate the x. To do that, I'll move the 4 over and get rid of the square, okay? So add 4 and take the square root. So to do that, first thing I'll do is add 4 to both sides. And then I'll have x squared equals 4. And then I'll take the square root of the left and the right, okay? Now, this is one big mistake most people make. When they take the square root of a square, they forget the negative solution, because if you're taking if you square a negative and a positive number, you get the same output, right? So some people just say, oh, this is 2, and they'll select option number 2, which is wrong. Okay, there are two solutions to this equation, positive and negative 2. Okay, so x equals negative 2 or 2. So if you want to use this method, remember to insert a plus or minus when you take the square root of a square. Okay, so there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here. If you like this video, you can click down here to like it. Please post a comment to tell me what you think about this video. More videos can be found on mathcoachserve.com. Thanks again and have a wonderful day.